Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a very nice computation problem. So we have this equation. In other words, there is a complex number z with imaginary part 164 and a positive integer n such that z over z plus n equals 4i. And we're going to be finding that integer. So AIME is a 3-hour test where you have to answer 15 problems. And the answers are integers 0 through 999. So it's a pretty difficult test, but this is problem number 2. So that's one of the easiest problems on AIME. That's why I picked it, right? All right, cool. Let's go ahead and take a look at this equation. So we have z over z plus n equals 4i. Now, one thing we know, which is valuable obviously, is that the imaginary part of this complex number is equal to 164. In other words, an n in this case is a positive integer. In other words, when we write our complex number as a plus bi, we can basically say that, hey, b is supposed to be 164, so we can basically write it as a plus 164i. So this is kind of like a half the work that we need to do, so we just need to find a. Of course, our goal is not to find a, our goal is to find n. Okay, let's get to work. And I'll be presenting two methods. And let's start with the second method. Okay, we haven't done second method first for a while. So for my second method, I'm going to do the following. I'm going to write this z over z plus n as follows. Now, when you have a fraction like this, a lot of times we do this. It's kind of like partial fractions. We can break down the numerator to make it look like the denominator. So in other words, we can just add n and subtract it. So that way, we can separate this into two fractions. So this becomes 1. So 1 minus n over z plus n equals 4i. And then our goal is to basically to leave all the variables on one side and everything else on the other side. So let's go ahead and do the following. Subtract 4i and add the n over z plus n to both sides. So now we kind of got one complex number on one side and something else on the other side. But we want to be able to split it up again, and obviously adding z is not going to help because it's going to bring us back. So instead of that, we want to make this separable. So let's go ahead and, not in the differential equation sense, let's flip both sides. If you flip both sides, then you can basically split it up into two fractions because this becomes z over n plus 1. Makes sense? Now, on the left-hand side, all the way on the left-hand side, we do have a complex number. It's actually division. So let's go ahead and multiply by the conjugates. And then when we multiply 1 by that, we get 1 plus 4i. And at the bottom, remember, the product of complex number and its conjugate is always a real number, and it's the sum of two squares. Remember that? A squared plus b squared, that's going to be 17. So now this equals z over n plus 1. So how do we handle this, right? Now is the time to replace z with what it is. Let's go ahead and do that. So remember, z was a plus 164i because we were given that the imaginary part is 164, so z is a plus 164i. And let's go ahead and, let me fix that real quick. And let's go ahead and plug it in. Replace z with a plus 164i divided by n plus 1 is equal to 1 plus 4i divided by 17. Awesome. So our goal is to find a and n, whichever one. I mean, if you can find n directly, that would be awesome. But let's see how this goes. Let's go ahead and split it up into real and imaginary parts. Now, on the left-hand side, I have a over n. Obviously, a and n are both real, right? Plus 1. And then I have 164 over n, I. And on the right-hand side, I have 1 over 17 plus 4 over 17, I. So here's what I need to do. I need to set the real parts equal to each other and the imaginary parts equal to each other. So here's how it goes. The imaginary part here and the part here, we can set those equal to each other directly. And guess what? That's going to give us the value of n directly. We don't need to find a. It's not asking for a. The problem is asking for n. That's the goal. So we can go ahead and set 164 over n equals 4 over 17. And if you do the work here, you can go ahead and divide this by 4. That's going to be 41. And then 41 times 17 is going to give you the answer. So n is going to be 697 from here. And that brings us to the end of the second method, but not to the end of the video, because we still have to do the first method. Let's go ahead and talk about the first method. So again, the problem was finding the n, integer, positive integer value that satisfies this. We know that the imaginary part of our complex number is 164, and n is a positive integer. Okay? Now let's see how we can do this with the first method, which should be pretty straightforward. Just replace z with a plus 164i. Now before that, let's go ahead and cross multiply. We get 4iz plus 4ni. And now let's replace z with a plus 164i equals 4i times a plus 164i plus 4ni. And then we just need to do a little work. A plus 164i equals, this is going to give us 4ai, and then I times I is I squared. Remember that? That's going to give us, the product is going to be 656, but with a negative sign, because I times I is I squared, and I squared is equal to -1. Make sense? Okay. And then we're going to have plus 4ni. So we can kind of put this together like that. A plus 164i, and then real part is -656, and the imaginary part is 4a plus 4n all multiplied by I. Now, again, our goal is to find n, but in this case, we kind of have to find a as well, because from here we get a equals -656, and then we also get 4a plus 4n is equal to 164. Let's go ahead and divide both sides by 4 before things get more complicated. And this is going to give us 41. And since a is -566, you have to add it to 41 to find n. And from here, n is going to be 697 as before. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.